Well, hey guys, welcome back to Automotive Insight. Today we have a 2010 Dodge Charger. Customer's concern is that the fuel gauge doesn't read or it doesn't read accurately. A little bit of background, they've already replaced both of the sending units. This thing has a kind of a saddle tank style gas tank and it has two sending units. Both of them have already been replaced. Who knows whether they're any good or not, but anyway, we're going to dig into the diag a little bit. Let's get to it. So we do have a DTC in the instrument cluster. It's for the fuel level sensor 1. So let's go look at the data list and see what we got going on there. So with our custom data list, we can see that the right side is showing 5 and some change volts. Left side is showing 0. So let's get digging around back there and see if we can see something obvious. The fuel pump and sending units are underneath the back seat. It comes out real easy. There's just two clips on the front, and then it'll just pull out. We're going to be looking into underneath this panel. So we're at 5.6 volts on the right, 0 at the left. So we're going to check and verify that that's actually what we have. 5.5, that's pin 1, that's the right one. The middle one right beside it, take that off. The middle one right beside it is a shared ground that they have, and then pin 3 is supposed to be the fuel level number 2. So we just verified that it's reading what it's supposed to be doing. Let's unplug it and see if we have some kind of a change in anything. So with it unplugged, we're reading 8.7 and still 0. Let's see what the right side input actually is. I don't know how well you can see it. It's 11.4. Our battery's a little discharged, but that's source voltage. Now go to pin 3. Pin 3 is nothing. So let's run a little experiment here. Apply source voltage to pin 3 and let's see what happens. Alright, so now they're the same. So let's dig into the wiring diagram a little bit and see if we can come up with a plausible explanation for this. So looking at our wiring diagram, honestly, it doesn't do a whole lot of good. You can see that the wires that we had 5.6 volts on and 0 volts, they just go straight up to the instrument panel here. This doesn't do a whole lot of good because it doesn't exactly tell you what is power and what is ground, but we can make a couple of assumptions given that this one's clearly the ground, and we know with this disconnected we have 12 volts on this pin. So we should assume that we should have 12 volts on this pin. But what's odd is when we put 12 volts on this pin, it's reading fine over here. So that lets us know that that wire is good and it's technically capable of doing what it's supposed to be doing inside of here, but that doesn't really answer the question. So at this point, we could basically condemn this instrument cluster. This is the instrument cluster. We could basically just condemn this and put a new one in it, and that would fix the car. But let's dig into like what's going on. Why exactly can we put voltage on that sensor 2 and get it to read up here, but it won't do what it's supposed to do otherwise? So let me draw something out for you. So this is what I'm assuming is going on here. I just kind of redrew this because finding internal schematics of what's going on inside of a control module, it's like pulling teeth. For whatever reason, you just can't hardly find it, but as a general rule, what happens is anytime that you have a control module, in our case it's the instrument panel, and it's outputting a voltage to something, generally speaking, it's going to go through a resistor first inside of that control module. And then it's going to tee off and go to some form of processor. So the reason that it does that is twofold. Number one is that this is how the module is able to tell if you have a short or an open. So let's say that we just cut this wire right here, and we had an open here. The computer would know that it's open because we have 12 volts coming from here. It's going through this resistor, but since the path is not completed to ground, you're still going to have 12 volts all the way up to here, and you're going to have 12 volts to here to your processor. So that's how you know you have an open. Now, say that you took this and you shorted it to a ground source. Same thing. You're now completing this path, and you're dropping voltage across this resistor, and so the voltage is going to be different here, and it's going to go to your processor, and that's how you know that it's shorted to ground, because it's expecting something else. So my theory here is that we have an open or something wrong between here and here. So probably a blown resistor or something, but that would explain why we don't have 12 volts coming out of this, but yet when we apply 12 volts to here, the processor is doing what it's supposed to be doing and we're getting a reading. So that's just my thought. Printed circuit board stuff is not something that I do a whole lot of, mostly because it's very difficult to find any schematics for anything. So you're having to do a lot of guessing. So anyway, we'll take this apart and see what's going on here. If it's a resistor, we might try to replace it. If it's a solder joint or something, we might try to resolder it. If it's something else, I don't know. But this is my best guess as to what's going on inside of here. So let's get it apart and see what's going on. Get the panel out. You're going to have to take off that piece there on the side. Take off this bottom. Move your hand. There's a Phillips head there and another Phillips head over the...
Is there one? I don't think so.
Oh, or not. There's a Phillips head there, and we'll pull out the bottom part, and that'll give us access to the top part. In theory, yours should have some Phillips head, well, I'm assuming Phillips head screws, or maybe Torx or something there, and I can't see it. Oh, right there. Ours aren't there, so other than that, it should just pop right off. Cluster comes out with 4 Phillips head screws. I was actually going to slow this down to half speed.
Yeah.
Now we're going to get working on taking the back side of this off. It is a T15 Torx bit. There are roughly 13 or so, 14 maybe, screws holding it together. So now we're going to try to get access to the kind of the other side of this board. We're going to take the 2 remaining T15s out on this side, 2 remaining out on this side. And disconnect that one connector right there, that ribbon cable. Now we're going to pull the needles off of our gauges here. What we were expecting to see didn't actually happen. So this one is, we're checking, this is the one that is bad. And as you can see, that's 96 kiloohms. And then if we check the one right beside it, the one that's currently working, it's 45 kiloohms. Now, we checked across both of these resistors, and they are just different resistors, different resistance resistors. So we went and plugged it in the car, and it was working. Now they're both currently reading 8.7, which is what it's unplugged right now, which is what it was reading when it was unplugged. If we go back and check for voltage, we've got, that's the one that was good before. We now currently have source voltage at the other one too, so it's currently working. So what we're assuming is that that solder joint between that pin and that resistor right there must be weak or bad or something, because it works sometimes and you can kind of wiggle on it and it'll quit working. So we are going to resolder both C68 and C70 just for good measure. Now with a scan tool, we're going to do a little bit of due diligence and sweep these. So we're going to start with the temp. Remember in our tool video we were talking about magnetic tip screwdrivers? Those sure would be nice. Well, it's all back together. Fuel gauge is working. We wiggled on the back of that connector a little bit. Everything's working fine. So other than some labor and a few cents worth of solder, this one's fixed. Not to pat ourselves too much on the back here, but this is a great testament to why you diagnose cars. This is really a great example of the difference between a mechanic and a technician. Most kind of backyard mechanics, which I mean we kind of are, but we also do this professionally, they're going to look at that code, they're going to say needs a fuel level sender, they'll stick it in, didn't fix the problem. Matter of fact, that's actually what happened on this one. They replaced both of them, still didn't fix it. This is why we diagnose cars, and this is why when you go to pay labor for something, skilled labor, it's worth it in the end, because you're not shotgunning parts at the car. You actually get to the bottom of it and get the car fixed. So anyway, that's going to wrap this one up, guys. Hopefully we earned a thumbs up from you. Let us know what you think down in the comments section. We have new content for you every single week, so consider subscribing to the channel. And with all that being said, thanks for watching. We'll see you on the next one.